In this video, we're going to take everything we've learned with first and second derivative tests to come up with the graph of f, but the twist is going to be that we don't know what the function is that we're graphing. What we're going to be given is our graphs of f prime and f double prime. So let's look at the graph that we have here, and let's say that our red graph is the graph of f prime of x, and our blue graph is the graph of f double prime of x. And what I want to do is come up with a sketch of f of x. Well, what we're going to do is we're going to go back and do like what we did when we had these problems algebraically. We're going to make some sign charts. And what I would do is look at my derivative of f prime, and remember, how did we figure out the numbers we put on the sign chart? Well, we wanted to know values that made that derivative either be 0 or undefined. Well, if I look at my derivative, it's equal to 0 right here when it touches the x-axis, and then again here where it touches the x-axis, and so I have two critical points, -2 and +2. Then the next thing that we would normally do would be to pick some values on either side or in those intervals. So let's use -3, 0, and 3 and see what happens. So if I use -3, let's look at our function. If I go to -3, the derivative is up here, it looks like 5, and so it's positive, so we'll fill in a positive there. If I use 0, the derivative of 0 is down here at -4, so it's a negative value. And then over here at 3, the derivative, I'm not exactly sure where that's at, possibly around 6. So that is a positive value, even though I may not know exactly what the derivative value is. I can tell from the graph it's positive. So I now know that my graph, we're going to look at this and assume that maybe this could be a polynomial function. So it looks like this graph would be increasing, then decreasing, then increasing. So we can at least list that out like we did before. So we're increasing from -∞ to -2, and then from 2 to infinity, we're decreasing from -2 to 2. It does appear we've got a relative max and a relative min. Now the difference is we can't tell what the y values are because we don't have a function to substitute in. But it does look like we have a relative max at x equals -2 and a relative min at x equals +2. Now let's make a second derivative sign chart. So now we're looking at the second derivative, and the second derivative is our blue graph. And again, remember that we wanted to find values that would make that 0. Well, that graph is 0 right there at 0, where it touches the axis. So that's my critical point. So we'll pick a number to the left of that and to the right of it. So let's use -1 and +1. So substituting back into the derivative, the second derivative this time, if I look at -1, the second derivative is here, maybe close to -2, but I do know it's a negative number. At +1, it looks like the second derivative's up here at +2, so it's a positive number. So now we know some information about our concavity. So we can figure out that we are concave up from 0 to infinity. We're concave down let's say from -∞ to 0. And it does appear that we have a point of inflection. So we'll just label that as POI. And that's going to happen at x equals 0. Now when I get ready to sketch this, I need to keep in mind that I don't have any y values that I have. So I'm just going to be giving a possible graph. There's more than one correct answer to this. So I'm just going to make some guesses at where I think these things could fall. So let's start by plotting points. We have a relative max at x equals -2. So I'm going to come up here at -2 and just put a dot here maybe at +5 and say that's going to be my max. My relative min is at x equals 2. So I'm going to come down here and let's say put a dot at -3 and make that my min. And we have a point of inflection at 0 something. So I'm going to kind of put that maybe right here at 2. And then let's look at what our graph is doing. It is increasing first, and looking at my second derivative sign chart, it is concave down. So we'll divide this up into intervals again. So up to -2, since that's my first dot, we're increasing concave down. So it should be coming up like this. Then when I get to -2, I change to decreasing, but I'm still concave down until I get to 0. So now we've started decreasing concave down. Then at 0, all we do is change concavity. So from 0 to 2, we're still decreasing, but we've now changed to concave up. And then from 2 on, we are increasing, and we're still concave up. So that's going to look something like that. And so this would be what I would suspect that my graph of f of x should look like. And if these are polynomials, it should make sense that that would be reasonable, because if I look at f of x, that appears to be a cubic function. Its derivative, that was the red graph, appears to be a parabola. And then the derivative of that, which would be my second derivative, which was my blue graph, appeared to be a line. And that is reasonable if this actually is a polynomial function. So what I would suggest you do is when you're working with functions where you have graphs, go back to a sign chart because you're familiar with working with those algebraically, and then use that information to help you get your graph.